In the previous video I ran through things rather quickly, so I wanted to go back and take some time to go through the actual steps with them written down for you to see. Let's try that again in slow motion, zoomed in a little bit, putting my calculator over there so we can see better. We have a set of data of the form concentration and time. We're going to go to stat, and it says edit at the top. That's what we want to do because it gives us the opportunity to edit our lists. Now I already entered my time and concentration data in those first two lists, and I want to calculate that natural log of concentration and 1 over concentration in my next lists over. So I just go to those list headings and do to our concentration, L2, whatever we need to. So L3 there is going to be the natural log of, second 2 is L2. And then to get my L4, I want that to be 1 over concentration. So I'm going to go to the heading there, 1 divided by L2, my concentration. All right. So we have that information now. At this point, we're going to go to graphing and see which one's linear. All right. We talked a little bit about that. So I'm just going to go to second, stat plot, which is y equals, and I'm going to hit enter, make sure that's on. And I'm going to make sure that what I'm going to graph is the x list that I want, in this case, time, and then our y list, which is going to be one of those things each time we try. All right. So I've got, in this case, my x list is already L1. My y list I want to be L2. We'll give it a try. Second, L2. All right. Then we can go to the graph, and it's probably not going to be visible. So we're going to hit zoom 9, which is stat zoom. That is not linear. And then if the answer is no, we're going to keep trying. So by keep trying, it means try the L3 over there. And all we have to do is change what our stat plot is graphing, second y equals, enter, change it from L1 and L2 to maybe L2 and L3. Graph it, right? Zoom 9 gives us a line that is not linear once again. So if we look at our plan says, is it linear? No, keep trying. So we're going to try our other one. Go back to your stat plot. We need to tell it now, I want to try L1 and L4, which in this case is 1 over concentration. So second L4, graph it, zoom 9, definitely a straight line. If we weren't sure, we can take a look at the r squared value, and we'll talk about that in a minute. But now we do have a straight line, so we can go on to the regression step, which will take place right here. For those of you who've done some graphing or statistics functions, linear regression is just the way that you find a fit line to a linear set of data. And so we're going to use our linear data, which for us was L1 and L4, the time and 1 over the concentration. And we're going to calculate a linear regression. And again, that's a stat function, so we're going to hit stat. And we want to move it over to calculate. All right, so we used edit before when we were up here. We're going to use calculate now. And I want linear regression. That's number 4 in this case, linear regression ax plus b. And when we go down there, it's going to ask us to set what is our x list and y list. And I want my x list to be time, which is not terribly on the screen, and then also L4, which is 1 over my concentration. So I'm going to go L1 and L4. You can just hit enter on the rest of these things, and it calculates some information for you. And I do need to zoom out in a moment, but first of all, it's a straight line, slope-intercept form, y equals mx plus b. My slope is 0.0225, and that is my value of k, right? And my intercept is 1.06, which is 1 over my concentration, and my r squared value is 0.99999, which is pretty darn close to 1, which tells us it's pretty linear, all right? I will pause for a second because I do want to show you for comparison. We looked at it and we said, yeah, it's straight. Our regression is telling us that 0.99999 is really, really close to 1 and it's straight. What if we were to compare that to, like, our second graph, which may not have been obviously not a straight line. So if we had done L1 and L3, which was natural log of concentration, we calculate it, and we end up with an r squared value of 0.89, which is much farther from 1, which means much less linear. And we might as well, just for our own sake, calculate it for the first pair of data. And we see an r squared value of 0.61. So our best case scenario here was our original 1 over concentration versus time. And I'm going to pull that back up and I'm going to zoom out, so it'll just take a second here. I just went back and did the regression on our time versus 1 over concentration. I have that information there. Just a quick note of how I set this up. I wrote down that the absolute value of A is our K. If you consider that for 0 order, the slope is negative K. For first order, the slope is negative K. And for second order, the slope is K. If you just have your slope and say the absolute value of that slope, that's going to be your rate constant every single time. Your B value in the AX plus B is going to be either initial concentration for 0 order, or natural log of initial concentration for first order, or 1 over initial concentration for second order. And then our R squared, I just put a little note there that says how straight it is. And then you would then go on inevitably and use this K value in one of the integrated rate laws to do some calculations for concentration after a certain amount of time, find how long it takes to get something, or other things like that. But this video was just for using those calculators right there. And I'll do one more quick video with that exact same set of steps just so you can see it again.